Good morning, afternoon, or evening, cats and dogs. For this video, you want to have out your lesson 5.8 guided notes. Previously, we talked about how to find the greatest common factor, or GCF, of a set of numbers. So what we're going to do today is practice factoring using the GCF, or greatest common factor. There are three main steps to follow. The first step is to find the GCF of the two terms, or the greatest common factor of the two terms. The second step is to rewrite each term as the product of the GCF and its remaining factors. The third step is to write the GCF outside the parentheses, and the remaining factors in operation will be left inside the parentheses. Basically, what we're doing is undoing the distributive property. There are three examples typed up here. We're going to work through this step by step, so I'll show you how this works, but if you want to look through these three examples on your own, you certainly may do so. I do have a very short half-sheet extra practice on this that you will receive, so in case you want some additional practice with this concept, you'll be able to get that practice. So let's begin with our first question. Number 9. The directions ask us to factor each expression. That doesn't mean just finding the greatest common factor, and we'll show you that. If the expression cannot be factored, write cannot be factored. All of these will be able to be factored. When you get into algebra or any level beyond that in math, you may have some expressions that cannot be factored. So in number 9, I have 3n and 12. The greatest common factor of 3n and 12 is 3. It's the largest number that both 3 and 12 divide by. So I rewrite this as 3 times n, since 3 times n gets me 3n, plus 3 times 4, since 3 times 4 gets me 12. Notice how my GCF, which I'm going to highlight in yellow, is used twice. Now the GCF is what's going to go outside the parentheses. What's going to be left inside the parentheses is going to be the terms that I have underlined or highlighted in green that are left behind when I take the 3 out of each of these terms. One way that you can check to see that if you are correct is to use the distributive property and multiply it out. So I know that 3 times n gets me 3n, 3 times 4 gets me 12. Something you should always double check as well is make sure there's nothing for the terms inside the parentheses that you can divide by besides 1. So if I'm factoring 3n plus 12, it factors into 3 in parentheses n plus 4. All right, let's try another one. Number 10, we have 5x plus 10. The greatest common factor of 5 and 10 is 5. So I rewrite this as 5 times x plus 5 times 2. Notice how my GCF is going to be used twice. The terms that are left behind are the x and 2. 5 times x gets me 5x, 5 times 2 gets me 10. We always want this to be equivalent to what we started with. So for my final solution, the 5 goes outside the parentheses and x plus 2 is left inside the parentheses. To double check, multiply it out using the distributive property. 5 times x is 5x, 5 times 2 is 10. You should eventually get to the point where you don't need to show this step. If I'm doing these kinds of problems with an 8th grade class, they're probably not going to show this step. They'll go right to this solution. Number 11, we have 9m plus 12. Even though they both don't divide by 9, 9 and 12 both divide by 3. So that's our GCF. So we have 3 times 3m, which is going to get us 9m. And then we have 3 times 4, which is going to get us 12. Again, my GCF shows up twice, and then these terms that are in green are going to be what's left inside the parentheses. So the 3 goes outside the parentheses, 3m plus 4 goes inside the parentheses. 3 times 3m is 9m, 3 times 4 is 12. All right, let's move ahead to our next 3. So number 12, I have 15 plus 25x. My greatest common factor is 5. So we will write this as 5 times 3, whoops, wrong color. We will rewrite this as 5 times 3 for 15, 5 times 5x for 25x. The 5 or GCF goes outside the parentheses, 3 plus 5x is left inside the parentheses. The only difference with this one is that our x term comes after the constant, but it doesn't matter. We treat it the same. In number 13, we have a to the second power plus 7a. For this one, the greatest common factor, this one's a little strange, is a, because I can take an a out of each of these terms. That's a little more challenging than what you're going to see on your test, but I still think it's good to practice. So my GCF is a, so I have a times a to get a squared, and I have a times 7 to get a 7a. So the a goes outside the parentheses, and a plus 7 is left inside the parentheses. We can multiply this out. A times a is a squared, a times 7 is 7a. All right, number 14, my apologies. I don't think I corrected this on I corrected it on my Word document, but not the PDF version. So this should be 14b plus 28. Take this extra b away. We do not need that b there. My apologies that I forgot to take it out. So it should read 14b plus 28. Now, my greatest common factor of 14 and 28 is not 7. It's not 2. It's 14. So rewrite this as 14 times b plus 14 times 2. You've got to take the greatest common factor out. So 14 goes outside the parentheses, b plus 2 is left inside the parentheses. You can double check it. 14 times b is 14b, 14 times 2 is 28. If you only take a 7 out, you're going to end up with this. You're going to end up with 7 and then in parentheses 2b plus 4, and you can divide both 2b and 4 by 2. So you would be able to simplify this further. So again, you want to make sure you take the greatest common factor out for it to be factored completely. This, while it's equivalent to what we started with, is not completely factored. All right, let's move on to number 15. 9 plus 48r. The greatest common factor of 9 and 48 is 3. So we're going to rewrite this as 3 times 3 for 9, 3 times 16r for 48r. So the 3 goes outside the parentheses, and then 3 plus 16r is left inside the parentheses. Number 16 is a little tricky. The greatest common factor of 4n to the second power and 16n is 4n. So let's try this. We know that 4n times n gets us 4n to the second power, and 4n times 4 gets us 16n. So the 4n is going to go outside the parentheses. N plus 4 is going to go inside the parentheses. We can double check this. 4n times n is 4n squared. 4n times 4 is 16n. Now with subtraction, we're going to treat this the same. So number 17, I have 8w minus 12. The greatest common factor is 4. So we know that 4 times 2w gets us 8w. And 4 times 3 gets us 12, but notice the subtraction between those. I'm going to highlight that in blue. So the 4 is going to go outside the parentheses. 2w minus 3 is left inside the parentheses. You can certainly add the opposite and rewrite this as 2w plus negative 3, but it's not really necessary here. Number 18. Our greatest common factor of 12 and 12 is 12. So we can rewrite this as 12 times p minus 12 times 1. Don't forget that 1 there, since 12 times 1 gets us 12. The 12 is outside the parentheses. P minus 1 is left inside the parentheses. Number 19, the greatest common factor of 6 and 39 is 3. So we can write this as 3 times 2g minus 3 times 13. The 3 goes outside the parentheses. 2g minus 13 is left inside the parentheses. While this topic itself, before we see our last question here, is not super difficult, most students pick it up pretty quickly. It's very easy to forget it before the test, so it's something you want to make sure you review before we take the unit test. In number 20, we have 3 terms, but we're going to treat this just the same. The greatest common factor of 7x, 14y, and 28 is 7. So we can rewrite this as 7 times x plus 7 times 2y for 14y and 7 times 4 for 28. So the 7 is going to go outside the parentheses, and we're going to have x plus 2y minus 4 inside the parentheses. Again, you will have an extra practice sheet on this, so I'll make sure to get that out to you so you can try some practice on this. You may want to even wait until closer to the unit test to do so, just to review this as close to that as possible. Let's look at number 21. It's completely done for us. It says the area of a rectangle is 6x plus 12 square inches. Factor 6x plus 12 to find possible dimensions of the rectangle. So the greatest common factor of 6x and 12 is 6. So we factor this into 6 and then in parentheses x plus 2. So the possible dimensions for this rectangle, since the area is length times width, are 6 and x plus 2. Let's do this for question number 22. The area of a rectangle is 5x plus 15 square feet. Factor 5x plus 15 to find possible dimensions of the rectangle. Well, the GCF is 5. So this factors into 5 times x plus 5 times 3, or 5 and then in parentheses x plus 3. So our possible dimensions for this rectangle are 5 feet and x plus 3 feet. All right, let's take a look at number 23, last one. The area of a rectangle is 12x plus 18 square meters. Factor 12x plus 18 to find possible dimensions of the rectangle. The greatest common factor is 6. So factor this into 6 times 2x plus 6 times 3. Pull the 6 out, put our GCF outside of the parentheses, and then 2x plus 3 inside the parentheses. So our possible dimensions are 6 meters and 2x plus 3 meters. It's nothing crazy. It's really just factoring the expression and applying it to a real life situation. Now again, I can't stress enough that I am going to give you some additional practice on factoring. It's not a major part of your test, but it will be on there. So you want to make sure you have an understanding of how to factor expressions. It's also a really big topic when you take algebra, more than likely in 8th grade. So it's something you want to have some familiarity with before you get into algebra. Thanks for listening.